Hi everyone, this video is how to apply congruence in triangles. We have definitions, theorems, and a few examples. All the answers are already written, so it's more of a definitional type video. So we have some vocabulary. We're mainly talking about triangles in this video. So in two congruent figures, all the parts of one figure are congruent to the corresponding parts of another. And in congruent polygons, the corresponding parts are the corresponding sides and corresponding angles. So identifying congruent parts, if we have to identify it, what you do is you use ticker marks. So for example, you have ABC, and what you want to do is turn around HFG to make it a little easier. So this would be E, there would be F, H, and G once you turn it around. So these two sides are congruent. These two sides are congruent. These two angles are congruent. And these angles are congruent. So that's what the congruence means. All right. So we have some examples. To find the value of x and y, they give us the diagram. And what you want to do is turn this diagram around so it matches. And when you do that, you'll know that angle Q, where's Q, is congruent to angle W. So if we drew this figure, the first figure, then we want to draw it exactly the same. I'm not drawing this very well. So it's kind of like that. You're just flipping this one over. So if Q is congruent to W, then W would come here, and QR is congruent to WX. So just switch these around, and you can solve for X. So to solve for X, if they're congruent, you set them equal to each other, and then just solve for X. And the same for that. But just turn your figures around. So it's saying here that FGHJ polygon, FGHJ is congruent to STUT. So you just write down the corresponding angles. If it helps to turn around the diagram, you do. That's what I usually do. And then you just write down the sides. And then to find the value of x, you just look at, you set these equal to each other. So you set x, 2x minus 77 equals, so that's FG, so that would be 103. Add 77 to both sides, and you get 180 equals 2x. And then you just divide both sides by 2, and you get x equals 90. And then you just find the measure of G equals 103, because these two are congruent. All right, and then we have this map. If you cut the map in half, will it be the same size and shape? The answer is yes. And basically, it has a lot to do with your alternate interior angles theorem. So when you cut it by the diagonal, angle 2 and angle 3 are congruent, and angle 4 and angle 1 are congruent. These are right angles, and you have the congruent sides marked as well. Okay, and then we have this third angles theorem. So basically it's saying that if two angles one triangle are congruent, then it follows that the other angle is congruent. So we have this, and that means C is congruent to F. That's the third angles theorem. So we're using this, find the measure of V. So what I'm going to do is look at, this is 44 with the vertical angle theorem. So I can make that 44, and I can find angle 6 by, angle S, by saying 180 minus 66 minus 44, and that gives you 70. So if this is 70, then, and these angles are congruent, then that means our angle V is also 70. And so that's using the third angles theorem, because they're already marked for you. Prove, in this section we're going to prove that triangles are congruent. So we write the given, and then because we want to go to triangle FGH is congruent to JGH, we're using the reflexive property of congruence. So we can get HG in the part. And then we're also using our third angles theorem. So basically, if you have your third angles theorem, then that means that these angles are also congruent. Right? And here's another theorem that we're going to be using. We have the reflexive property of congruent triangles, the symmetric property of congruence, that's where you just switch these around, and the transitive property. So if A is congruent to B, let me write it down here. If A is congruent to B and B is congruent to C, then A is congruent to C, because these two are the same. I didn't want to write all that out, but that's what the transitive property is. And we've already talked about that in class. So we know that D, so it says in the diagram at the right, E is the midpoint. We know these two angles are congruent. So we want to show that ABE is congruent to CDE. And from the diagram, we know that AB is congruent to DC. Point E is the midpoint. So these angles are congruent. And then we also showed that AB is perpendicular to CD. So angle A is congruent to angle C, and then therefore B is congruent to angle D. And since all the sides and angles are congruent, that means the triangles are congruent. So based on this diagram, what's the measure of D? So we know that our vertical angles theorem states that this angle here is 47. Then you take 180 minus 71 minus 47 to get the measure of angle A. And that's going to be 180 minus 47 minus 71. And that gives you 62. So this is angle A is 62. Since these two angles are congruent, then that means angle D, the measure of angle D, is also 62 degrees. And what additional information do we need to know? We must know that AB is congruent to DC, and BE is congruent to CE to conclude that the triangles are congruent. The rest we can infer from the graph. And that's it. Thank you. Have a nice day. Bye-bye.